Okay, here's this delta or change in problems that we didn't get to, or if I did, I kind of went through it quickly, but here's how to do this. So this is our cyclist traveling question. And so what we're given on this one is we're given this cyclist. He's traveling to the west at 14 meters per second. So here's my first velocity vector at 14 meters per second going that way. Then he turns due north at 10 meters per second. And then we're also given the fact that it takes 4 seconds for this whole thing to happen, okay? The question actually asks me, what is the acceleration that has to occur? So I'm going from meters per seconds, and I have to figure out what the acceleration is. Well, the first thing we're going to do is make sure we understand the acceleration is the change in velocity over the change in time. And thinking back to how that equation works, it's actually our first kinematic in disguise, right? But what we're doing is we're really looking at this version of the equation right here. So I'm going to use this acceleration equals Vf minus V naught over t. Now what's happening is, remember, this is happening in 2 dimensions. And what's going on in this y direction, or in the x direction, it's 14 to the left and it's 10 to the right. And what's happening is things are changing direction. So I'm going to use this right here. I'm going to switch to blue and call this my velocity vector. So my initial velocity in the x looks like it's negative 14 meters per second. Once again, negative simply because it's pointing to the left. And then I have what's going on in the second piece. So if this is the first vector I'm talking about, this is the second one. In the first one, I have only a velocity in the x direction. A final velocity in the x direction, so Vf in the x, is going to be 0 meters per second. In other words, I'm taking a look at point 2 over here, and it is only in the y direction. All right, so now I'm going to take a look at how this works in the x direction. Here I'm going to use my red. So my V naught in the y direction looks like it's 0 meters per second. So I'm looking at vector 1, it's all in the x. And then Vf in the y direction looks like it is a plus 10 meters per second. So what I've done is I've basically built my triangles here in terms of my acceleration vector. And if I look at how my acceleration is set up, I can say that acceleration in the x is Vfx minus V naught x over time. And my acceleration in the y direction, the same thing, Vfy minus V naught x over time. Oh, sorry, y in this one, my bad. So all we do now is start plugging stuff in. So for my acceleration in the x direction, I get my Vfx, well, that looks like it is 0 meters per second, minus whatever my V naught x is, which is negative 14, over the time. Once again, it gave me time, and I kind of forgot about him, but time is up here at 4 seconds, so over 4. So I get acceleration in the x, look like it's 14 over 4, which would be 3.5 meters per second squared, all in the x direction. That's the acceleration vector in the x direction. My y direction looks like I'm going to do exactly the same thing. A sub y equals Vfy is plus 10, V naught y is 0 over my 4 seconds. Acceleration in the y is 10 over 4, which is, calculate real quick, 2.5 meters per second squared. So notice I'm getting plus values for these. So now what I have to do is I have to sketch my acceleration vector. So my a sub x looks like it's pointing in that direction, and my a sub y is pointing up. So I guess I have to say not drawn to scale here. This is 3.5 meters per second squared. Oh, sorry, that should be y. I'm going to use this yellow. I'm just going to call this maybe bar A, like that, just showing you that that's the resultant. Pythagorean theorem gives us a value of 4.3 meters per second squared. So that's the magnitude of my acceleration vector. The angle I'm looking at for is right here. So it looks like I can use tangent of 2.5 over 3.5. So the math for that gives me theta equals the inverse tangent of 2.5 over 3.5, which now gives me an angle value of 35.5 degrees. The way it's setting up looks like it is going north of east, the way the problem set me up here. And that should make sense. So what's interesting is comparing that to my initial velocity vector. Remember, I had a velocity going this way at 14 meters per second. I wanted to sketch that in white, sorry about that. So I have this velocity vector pointing this direction here. Notice in the acceleration piece, the initial velocity went from negative 14 to 0, so that means I had to accelerate it in the positive direction, as indicated by my blue acceleration vector. And my initial velocity was pointed in the positive direction, and so it keeps going in that direction, and so my acceleration vector in the red must also point in that direction. So this is how we set up these delta or change in questions, right? This piece right here is what the resulting acceleration vector looks like. And that comes from this initial thing. Remember, initially I was going 14 to the left and then 10 to the right. And I had to accelerate, right? This is the acceleration vector of this particular object moving like that. All right, let me know if you have any questions. Thanks for watching. Okay, bye.